Three ways to express information. You can use a table, a graph, or an equation. So they gave us an equation and we're gonna graph it. But before we graph it, we need to draw a table. These numbers you see here, you get to pick. And notice how they were picked. I picked some negatives, 0, and some positives. That would give me a good graph. Some negatives, 0, and some positives. So now you input, you let the x equal each one of these. Notice how I'm replacing this x with each one of those x's. Then you simplify. And now we know that these x's are paired up with these y's. These are the inputs. These are the outputs. And notice I put parentheses. That reminds us that each one of these is going to be a point that we're going to plot. So now you plot it. Notice -2, -2 is here. And I go down 3. 1, 2, 3. So that's that first pair of points. -1, I go down 1. Second point. At 0, I go up 1. And at 2, I go up 3. Now I join those points and I have the graph. This is the graph of a line. Also, these 2 points are very important. This is called the x-intercept. That's where the graph, any graph, cuts the x-axis. That point, we call it an x-intercept. Where any graph intersects the y-axis, we call that a y-intercept. We'll be using that later. Find the x and the y intercepts. So this is the equation, and we would like to know where it intersects the x-axis and the y-axis. To find the x-intercept, you let the y equal 0. To find the y-intercept, you let the x equal 0. Notice it's like backwards. X-intercept, y equals 0. Y-intercept, x equals 0. So you go and plug in a 0 for the y. Then you simplify, solve for the x, and this would be x equal 4 is the x-intercept of that graph. That's where it would cut the x-axis. For the y-intercept, you let the x equal 0. So notice that's where the x was, and that's where you replace it with a 0. Then you simplify. Y equal 3 would be the y-intercept, where the graph intersects the y-axis. Now we have 3 forms of an equation of a line. This is called the point slope, the slope intercept, and the standard form. Notice for the point slope, they mention a point, x1, x sub 1, y sub 1. For the slope intercept, they mention the slope, which is the m, and the y-intercept, which is the b. And for the standard form, they have the x and the y on the same side of the equation. We mentioned a slope just a little while ago, and what's a slope? For example, the slope of a line or any graph is the rate of change. Whatever that graph represents, it's a rate of change. So a slope records the rate of change. Slope is rise over run. Rise up and down, run left and right. That's why we use these symbols. That triangle means change of y, and this triangle change of x. Change of y, change of x. And this is the formula we need to memorize. When you measure change, you subtract. Change is measured by a subtraction. So this is the way the y's are changing, and this is the way the x's are changing. They're asking us to find the slope of a line through this point and this point. The first step is you label your points. Who's going to be the point 1 and who's going to be point 2. It doesn't matter. At the end, you get the same answer. Since we're looking for the slope, you write the formula for the slope of a line and start replacing these variables depending on how you label this. So notice the y's go on the top, so that'll be 4 minus 8. The x's go in the bottom, so that'll be 5 minus a negative 6. You simplify. A negative times a negative is a positive. Keep simplifying. and you get a slope of negative 4 over 11. So the slope is negative 4 over 11. So this graph is falling 4 units down as it's moving 11 units across. So the rise is up and down, the run is left and right. More information on slopes and idea of slope. So here are 4 lines. We always read from left to right the way you read a book. That's the way you do math. So you read a graph from left to right. If the line is rising, we say it's a positive slope. If the line's falling, we say it's a negative slope. If the line is horizontal, we say it's a 0 slope. And if the line is vertical, we say no slope. Notice that 0 slope and no slope does not represent the same thing. So more stories about lines. The lines can be parallel. They could also be perpendicular. If the lines are parallel, then the slopes have to be equal. Because remember, slope has to do with steepness. They're just the same steepness. So the slope of one equals the slope of the other. If they were perpendicular lines always form 90-degree angles. And what happens to the slopes? We still are talking about the slopes. We're still talking about the slopes. But notice the relationship. If we have slope 1, slope 2 would be the turn it around and change the sign. We say the negative reciprocal. That's the relationship between slopes of perpendicular lines. So parallel lines. So if this is one of the lines, and this line is going to be parallel, if line 2 is going to be parallel to line 1 and 1 to line 2, their slopes have to be equal. Notice we don't say anything about anything else, just the slopes. The slopes are the ones that control parallel or not parallel. So if they're parallel lines, the slopes are equal. Notice for the perpendicular, the slope, which is the m in the equation, would be these two numbers. And notice the relationship. If the slope of the first line is 2 over 3, the slope of the second line would be flip it around and change the sign. So this is 2/3 of slope 1, and this will be negative 3/2 slope 2. Now, a very important fact, don't forget this. For you to be able to read the slope of the equation of the line, the y has to be by itself first. If it's not by itself, you need to get it by itself and then identify the slope. They're asking us to find the equation of a line through these 2 points. All you need are 2 points to define a unique line. 2 points are good enough. So first step, write y equals mx plus b. We had 3 ways to write the equation of a line, but this is one of the easier ones. So we're going to start off with this one. So y equals mx plus b. So all you have to do is go and find the m and put the number here, find the b and put the number here. Label the points. Once you label the points, you could use your formula and start substituting into your formula. Remember, the y's go on the top and the x's in the bottom. So it's negative 2 minus 4, negative 10 minus 5. So I subtracted the y's. They go on the top, that's subtraction, and I subtracted the x's. That subtraction goes in the bottom in the denominator. Now simplify and you end up with an m equaling to 2/5. Now you could put it where the m is. Instead of putting the m, you put the slope you found. So there it is. We just need to find the b. The b, you always find it the same way. Use one of the points to find the b. It doesn't matter which. At the end, you get the same b. So I picked this one because it looked like the easier one. Remember the first coordinate. These are called coordinates of the point. The x coordinate and the y coordinate. So I put the x where the x goes, and I put the y where the y goes. I substitute them. So now the only thing that's missing is the b. Simplify, get that b by itself, move this 10 over 5 to the other side by subtracting, keep simplifying, and b will equal 2. You could have also canceled these 2 and gotten the 2 from the beginning, but we were practicing moving fractions around. So b equals 2. So now you put that 2 where the b is. This is the equation of the line that goes to those 2 points we mentioned. Find the equation satisfying the given conditions. So now we want to find the equation of a line, but we want it to be perpendicular to the line they gave us. This is the line they gave us. We have to find another line that's perpendicular to this line and going through this point. Since you're looking for the equation of a line, write y equals mx plus b. This is your framework. From here, you know you have to find the m and the b. So since these are going to be perpendicular, and this is one of the lines, the relationship between the slopes when they're perpendicular is that you get the one they gave you, flip it around and change the sign. So I plugged it in here for the m. So I've got the m taken care of. Now the b, you find it the usual way. Use the point they gave you. This is x, this is y. Replace the x and the y with the coordinates x and y. Solve for the b by simplifying and moving everything to the other side. Finally, you have the b by itself. Now you can replace the b with what it is. It's an 11. This line is perpendicular to the one that they mentioned first. When you see the word models, linear models, the word model means that the information or the data you have comes from investigation or research. So model just means the information came from research, some study. So right here they did a study. And for a given year, they found out how many faculty there were. So if you see for 2005, there were 917 faculty, 2007, 990 faculty, and so on. Now, what we're going to do to make it simpler, instead of saying 2005, we're going to let x correspond to the year 2005. So this is x equal 5, x equals 7. This one is x equal 9, x equal 11, and so forth, x equal 13. Now, pick 2 points. We're going to have a linear model. In other words, we're going to come up with an equation that represents all this information. But you pick 2 points, and you could pick any two. So I pick this point and this point. Notice the first row are the x's, the second row are the y's. So here are my 2 points. I find the slope by using my slope formula, and I come up with a slope of 38.5. This time I'm going to use the other form of the equation of a line. Notice what's one benefit here, that you don't have to look for the b. It takes care of itself. This is the first form of the line that was given. It's the point slope. So we have the slope. Just plug in wherever point 1 is. Here are the numbers. Plug them in. Here and here. Notice y sum 1, x sum 1. That's where you put the 9 and the 1038. Simplify. And notice I put a little hat on this one that tells us that this one is the one that's trying to represent all the data. Even though I use 2 points, this is going to attempt to represent all the other points. So if you look at your table, we have a data point. This was in the table, 5, 917. And the model point is this. And you say, well, where did these come from? This came from the table. The data point came from the table. Actually, data point. This one came from letting the x, this x, be a 5, and it produced an 884. This is our model line. And now what we're going to do is we're going to see the other points, how close they get to our model line. The closer they get, the better this line represents the data. And how do you compare how close it gets, or find out how close it gets, or compare how good this line is? Because we could have gotten another set of points and got another line. What you do is you subtract the y's. Notice this is the data y, and this is the model y. So here they are. Data y, model y. Subtract them. This 33 is like a grade. So the model and the other data point are like this far away. We call this a residual. There's an error here. It would have gone, if the 2 points, if this point would have been on this line, this residual would have been a 0. So what you do is you get other lines with the other points, and you try to find the line that represents the data the best. We call that the line of best fit. You're only responsible for up to the residual.